Good morning, students. Today I'm going to review the material for exam 2 and go through the practice exam with you. But before I do that, I do want to put a couple thoughts out there for you guys to think about as you're working through the course. I have noticed a lot of you are starting to fall behind and are struggling with the content. And also in grading the first exam and the corrections on the first exam, it also appeared that a lot of you decided maybe you didn't need to study, or maybe you don't really understand how to effectively study for an exam. Um, so, just because you have the opportunity to earn back your points doesn't mean you shouldn't study for these exams. I would highly encourage you to. It means that you can get a better grade right from the get-go, and you don't have to write corrections after that point. The other aspect is it means less grading for me, which means I am available more to help you as you're working on milestones and things like that. So every time the TAs, have to do extra work on the grading side of things, that means we're less available for you. So if you can work at getting as good a grade as you can on your work and actually really doing the work, that saves everybody a lot of time and a lot of pain. Uh, as far as studying goes and also trying to learn content, there comes a point in every student's career that they may have been able to go through much of high school and possibly even the first few semesters of college without really learning how to study effectively. But there comes to a point where for everyone where we hit a wall and we just cannot continue the practices that we've been doing and still be effective at learning and developing our skills. And this is especially true in subjects like computer science, where what we're really trying to do is reformat the way our brain operates by adding new cognitive structures. And that's a very demanding process, and it requires us to grapple with those ideas over and over again. And there are some strategies that you can take advantage of that really will make that much more effective for you. And moving forward, I would highly recommend that you pursue those and really try to take advantage of those. For example, note taking. The act of physically writing out notes helps reinforce the connections you are forming in your brain as you are learning new content. So if you are not taking notes in this class, you are doing yourself a huge disservice. So one of the things I would highly encourage you to do as you are walking through the modules, as you are doing the exercises, as you are doing the readings, and even as you're working on your homework, have a notebook handy and be writing down notes about what you're learning as you go along. And a really good practice is to have more than one notebook. So you have one that's kind of your rough notes and a lot of maybe messiness, but you try to get as much down as you can. And then at some point, take those notes, copy them into a new notebook, but don't just straight up copy them, but actually try to organize them and try to put them into a better context than you have before, and use that as a way of going back over those notes, reinforcing that in your learning, and really thinking about how those different pieces connect. That's going to make you a much stronger learner. In fact, one of the strategies I used to talk to my students about when they came in for advising and told me they were struggling in their courses was to use the 3 notebook strategy, which means you have 3 notebooks. One that you take with you to class, that you take out during lectures, and you write down as quickly as you can the stuff the teacher's talking about in a way that you can hopefully remember it. And then, of course, because we never actually remember once we step away from that class, immediately or as soon as you can after that class, copy those into the second notebook, fleshing out all those thoughts. You're like, oh, I'll be able to remember that. That's not a big deal. Make sure you write all those down. And then before your exams, take out the third notebook and copy all of the content that's covered on the exam from your second notebook into your third notebook. It takes time, but if you do that, you will find yourself really reinforcing that learning, and you'll actually do much better on your exams. The other thing I want to draw your attention to along this is the Academic Achievement Center here on campus, and specifically their academic coaching programs. So if you have hit the point where you're finding yourself struggling to manage your time, you're finding a lot of trouble trying to remember the things that were covered in lectures or in the exercises and really apply them in the milestones for this course or for other courses, if you go and talk to the academic coaches here, their whole whole job, their whole role is to help you develop those skills so that you can succeed in your classes. And of course, there are some different options. They have a drop in where you can just drop in and talk with somebody, or you can schedule a meeting and really get a targeted one-on-one experience where they walk you through maybe some different study strategies that are going to help you, some time management strategies that are going to help you. All of these, by the way, are paid for through your student fees. So you're already paying for these services. You might as well take advantage of those. And I would really, really encourage you guys to do this, especially having come up through the advent of COVID and the switch to online teaching 100% and kind of the back and forth that we had along those times. You guys really have had a bit of a hard path in terms of developing your study skills and really being able to employ those effectively as your classes have changed on you, which means you may be a little bit behind where you should be coming into 400. And that's going to carry forward unless you address it now into all your future CS courses, because one thing you will find out is your CS courses all build on one another. And for those of you that are really struggling with just the basic fundamentals of programming right now, you are not really learning anything of the CS400 material. That's the reality of the situation. Is if you don't have the foundation, you're not going to do new learning. You're going to instead be trying to shore up your shaky foundations as you go through your courses. So if you're one of the people in that particular place, I would also highly encourage you to think about either retaking 400 or going back and retaking 300 as a way of shoring up those areas where maybe you just did not develop the learning that you needed to be the foundation for moving forward in your computer science coursework. Okay, so let's go ahead and flip and let's talk about our exam. So like before, we are going to have a number of vocabulary questions, and this list is kind of the fair game of things I might be asking you about. So things like the graphical user interfaces and how they work, component-based design and what that is really about, composition, events, the use of an event loop, an event queue, data binding, how that works, what it's really intended for and how you utilize it, the model view model pattern, which you have used in this last exercise, the as keyword, the is keyword, the pattern match expression. That's the one that you use an if statement. If something is a particular kind of object, and then it casts it and assigns it to that object. Xaml, which of course we've been working with this whole time. Code behind, which is the CS files that partner with our XAML, or in Windows Forms, the CS files that we write, the partner with the form that you've built in the designer. The elements tree, which is a WPF specific thing. That's that tree of elements that we compose of different controls all the way up to the window. Styles and how we can effectively use those. The resources, which are, for example, our styles or resources. The object data provider we use as a static resource. The event handlers and event listeners, what those are, what the difference between the two is, and how you use them together. So remember, an event handler is what you're defining in the class that is basically saying what the event's going to be, and the event listener are the message you write to attach to the event handler to get notified when the event happens. The data context, which is the object that we bind to a WPF element so that we can basically consume its data, display that, and potentially, if it's a two-way binding, also update that data. Dependency properties and routed events. So what all of those different pieces are, these are some of the terms that you should read up on. Be ready to write basically a short paragraph describing each one of these. So if you're not familiar with these terms, go back to the textbook, and I would actually suggest writing a paragraph describing each one of those and what they are as part of your study practice. Okay, jumping to the practice exam. Just again, we have our questions about vocabulary. What is event-driven programming? That's where we write a program that primarily is updated through events, which are often user events. It could be other types of events if we're doing something like a network program. A web server, for example, is a event-driven program that is driven by incoming HTTP requests. We're going to talk about that in the next series of modules. What is the purpose of data binding? Data binding, of course, is to connect the object that is providing data to some other object that's consuming that data. That's normally used for GUI design. So we have a GUI that's consuming some kind of data object. Doesn't have to be, though. There are other kinds of data binding that we can use in terms of connecting to networks or things like that. What does the term aggregation refer to? If you remember when we discussed our UML diagrams, aggregation is a has-a relationship, and it indicates that one class has an instance or multiple instances of another class, and it's a brother to composition. Composition also means that that class has a relationship with another class. The difference is aggregation is the soft relationship, composition is the hard relationship, because composition says that this class is always going to have an instance of that other class. So as soon as it's constructed, it also constructs the other class. They stay together for their entire life cycle, and then when those classes are disposed of, one is, the other one goes as well. Whereas aggregation is more of a loose relationship where we can switch between objects. So we have an instance of another object, but it could be replaced by a different instance at some point. So composition, for example, is how we compose our WPF elements, because we build them out of other WPF elements like buttons and view boxes and lists and grids. All of those are elements that are composing a more complex user control, for example, and then the window is composed of a bunch of those things. The aggregation would be more like when we attach something for data binding, like the menu items that we're using in our milestone. Those menu items are attached to, say, a screen that allows you to edit them, but then you can attach a different menu to it, or the order is attached to the main window, but it's not always the same order. We're creating new orders all the time. What is a partial class? So this just means a class that's defined in two files. That's really all it is. And we've seen this at multiple points in your CS career. You worked within 300 when you used Windows Forms. There's a CS file that is created from that designer where you lay out your controls. And then there's the code behind CS file where you write the logic that connects those two. The same thing happens in WPF. The XAML file that you write defines half the class. In fact, it gets compiled into a temporary class that is a C# file, and then the other half of that is your xaml.cs file where you write, again, the code behind code, and those get zipped together during compile time to make one full class. So partial just means that the class is partially defined in one place and partially defined in another. What do we use the is keyword for? Well, it is used for determining if a cast is possible, right? So if this object is an instance of another object, then you can use it as that object. It's safe to cast it, and you won't have a casting operation error when that happens. What is the purpose of the iNotify property changed interface? This is to basically make sure that a class is implementing the property changed event. It lets the other classes know that our object implements that event. For example, when we bind an object as the data context in our WPF elements, that binding class looks at that class that you've bound and asks the question, do you implement iNotify property changed? And if it does implement that interface, which we can test using that is keyword that we just discussed, then we know that we can attach an event listener to the property changed event handler. If it doesn't implement the interface, even if it has the property changed event defined, our binding doesn't realize that it has that, and it won't try to attach to it. So it's very important that we have that interface in the class declaration, and it's also important that we implement that iNotify property changed interface fully, which means we have the property changed event defined in the class, and that we invoke that property changed event whenever a public property changes in the class. Otherwise, when we connect it to through a data binding, if we change the value the data binding doesn't know the value has changed. That's exactly how that binding works. It listens for that property changed event. When that fires off, it then requests the new data and then updates the GUI to display it. So if you don't implement the iNotify property changed interface on classes that you're using data binding with, you don't get the full effects and the full benefit of data binding. All right, so let's look at our coding questions. We have diagrams on this last page, so if we flip back to that, we have a XAML for a customization screen. This is customizing Hagraven wings. So this is some kind of menu class with a lot of information there. And then we have the class for that Hagraven wings. It's implementing the iNotify property changed. It is inheriting from Entree, which is inheriting from iMenuItem. And then we have a couple enumerations. So let's jump back to what the question is asking. So we have tests, unit tests for that Hagraven wings. First, make sure that the default size is small. Well, if we go back and look at the Hagraven wings, we have a size property which has a get and a set, and we want to make sure that that is starting as small. So the first thing we do in that test is create a Hagraven wings by constructing a new one. And then we can assert that that Hagraven wings.size is going to be small, and we want to put our expected value first, so size.small and Hagraven wings.size. So that is question 1. And let's go take a look at our tests again. So that was this one. Then we have a theory. Looks like we need to provide the inline data, use the correct price for size. We're providing the size and the price. We're constructing a Hagraven wings, setting its size using initialization syntax. So this constructs the object and then immediately sets its size property to be whatever we passed in as this argument. And then we assert that the price, which we're bringing in as an argument, is the same as the wings.price. And because in this case we're using doubles, we're going to specify the precision, so the number of decimal places. If we use a decimal instead, we don't need to use that precision. That's specific to doubles and other floating point numbers. Okay, so this is a theory. We need to provide inline data. And the first argument is going to be our price, and the second, or to have that backwards, size, and then price. So we put the size first. So let's do size.large, and whatever the price for large should be. And size.medium, whatever its price should be. Okay, now we have those three sizes. We need to set the corresponding price, and those are found in the table at the very back. Notice that if we go in here hard, often it will be a table. This is an old practice test where I think we're still providing the information in one of the classes. Yep, so here in question 10's description. Small price is $4.50, medium is $5, and large is $5.50. So small should be $4.50. Medium is $5, and large is $5.50. And that should be all we need there. Now, like I said, this will actually be in a table rather than being in the heading of another question just at the end of the test. We started doing that a couple semesters ago just to make it easier to find the information you need. So that was this theory. We have another theory down here where it looks like we're bringing in dipping sauces from the dipping sauce enumeration, and we're looking for notifies of sauce change. So again, we're implementing iNotify property changed, which means we have a property changed event handler, which is defined. So when we create a Hagraven wings, and we set its sauce, we expect that sauce property to be notified that that's changing. So the assertion we use to check that is property changed. And we go hag raven wings. The second argument is a property we expect to change, which notice it is named sauce. Its type is dipping sauce, but its name is sauce. So sauce. And then we do an action which tells our assertion what it needs to do to actually make that change occur. So this would be taking our hag wave and wings and setting its sauce property to be equal to the sauce that's supplied as our argument in that test. So here we're taking a dipping sauce. We need to make sure that this is spelled exactly the same, which is lowercase sauce. We assign that. That should trigger the assertion. So that is this particular test. And finally, we should check that we implement notify property change. The test for that is pretty simple. We say hag raven wings, new hag raven wings, and then we want to do assert dot is assignable from, and then we just give what class we want to, or interface we want to test. So I notify property changed. And what this test is basically doing is asserting, we have to pass in hag raven wings. What it's doing is basically looking at this hag raven wings and asking the question, is it an I notify change? So something like if raven wings is I notify property changed. So if this cast is possible, then this is true. Otherwise, it's false. So it's just checking, can we treat it as an instance of I notify property changed? So that's our last test. Then we get to question 8. Draw the customized hag raven wings defined in the XAML as it will appear on screen. So we're going to do some drawing. I'm going to pull up Paint, and we're going to draw the customized hag raven wings control. So we've got a pretty beefy control here. Notice that we have a user control resources. We have an object data provider that is invoking the get values of enum on our dipping sauce, and then we're assigning that the key of sauces. So sauces is going to contain the list of all the values of our dipping sauce, and the same thing here, we're getting the values of the size enum, so that's going to be all our sizes, and we're going to save that as sizes. Then we have a style, which is targeting the list view item. So any list view item that we run into, we're going to reset its template so that instead of doing the normal thing for a list view item, which is just a text box with the item that's bound to it being displayed as a string, we're going to instead display it as a radio button. We are going to bind two-way to the is selected. So mode is two-way, the path is selected, and the relative source is the templated parent. So we're looking at the list that contains list view that contains this list view item, and we're asking the question, is this particular item the selected item in the list? If it is, our radio button will be checked, otherwise it will not be checked. And then we are also displaying the content is the content presenter.content. So whatever that object that we're bound to is, we're going to invoke its toString, and we're going to display that as the text of the radio button. So that's going to basically just use that enumeration. Then we have our grid, then we start a grid. We have 2 columns and 2 rows. The first row has a height of 50. So let's go ahead and draw out kind of what our grid's going to look like. We have one row that's going to be 50 pixels. From here to here, and then the second one is just going to fill up any remaining space. We have 2 columns. Notice that there's no size specified for either one, so they're going to divvy up the space equally between them. And then we have a text block, whose text is customized Hagraven wings. Its font size is 32, so it's going to be pretty big, and it's spanning 2 columns. We have no column or row specified, so it's going to actually end up in this column. It's going to span that column as well. So this is customized Hagraven wings, and we're going to span it across both, and we know it's going to be fairly big, so we actually want to display it big. And notice now we're spanning both, so we get that idea that it's spanning both. Then we have a stack panel. This stack panel is in grid column 0, grid row 1, so that means we're starting that down in here. It's not spanning anything, so it's just going to be in that row, and it has a text box whose text is size, and a list view whose item source is the binding source static resource of sizes. Now notice that we're putting this in a stack panel. We haven't changed the orientation to be horizontal, so it defaults to vertical. So we're going to put this text block in first. It's got a static text, which is going to be size. And this is going to be normal size text, so we'll drop that down to a much smaller size to reflect that. And then we have our list view. But remember, our list view, its items are going to be coming from the static resource sizes, which we got from this object data provider. So, this one. So it's going to be the 3 sizes that we have available, small, medium, and large. And the list view item we overrode to use this template of radio buttons. So what we're going to see is going to be radio buttons that are going to be small, medium, and large. And because these are radio buttons, we need to display that little button that we can go ahead and show. And I'm just, in this case, using a capital O, and then our small is going to be selected by default if we've got this bound to a Hagraven wings, which would probably be our assumption. Then we have another stack panel. This one's bound to column 1 and grid row 1, and notice that it has, again, a text block text for dipping sauce, and it's bound to that sauces using a list view, so it's going to also display as a list just like this other one. So we're going to say dipping sauce, and then we're going to have our dipping sauces, which are, look those up real quick, blue cheese, buffalo, honey barbecue, blue cheese, honey mustard, buffalo, honey barbecue, mango habanero, and ranch. And again, these are being styled as radio buttons, so we need to have the little radio button that goes with them. And we don't have a default listed for our dipping sauce, which means we're probably going to default to the very first one, which would be blue cheese, just to show that. And that wraps up our Hagraven wings. So, and if we look at the rest of that template, after that stack panel, we close out the grid, we close out the user control. So that is the entire answer. And if we wanted to, we could indicate that these are equal sizes, or just do our best to draw them as equal sizes. We could also write the size of the fonts next to things, just to be clear what font size it is. So actually these guys are 20 pixels. These are actually probably bigger than I've rendered them. And but smaller than the customized Hagraven wings. And then these guys, we did not change the font size of the radio button, so that would be the default, whatever default size it is. Okay. So that was draw the customized XAML. Write XAML to display a bound Hagraven wings size, sauce, price, and calories property. So this is going in a stack panel. We want to display their size, sauce, price, and calories. So let's start with the size. This is question 9. So we're in a stack panel. We could actually use a text block to display that. It didn't say they needed to be editable, so it doesn't have to be a two-way binding. So a text block is a one-way binding. We can say the text property is going to be bound to, and we need quotations around that, bound to the size property, path equals size, and we're displaying those, but we don't want to just dump them out there and just have it say large without any kind of real detail to it. So it's a good idea to either do a string format where we actually provide a bit of context to this. So size, colon, and then in brackets 0. What that's going to do is basically display the string size, colon, and then this bracket with the 0 is going to be replaced with whatever this size path is. So whatever the size is, it will be small, medium, or large. So we'll get size, colon, small, size, colon, medium, size, colon, large. The other way you can provide that kind of context is to have a second text block whose text is, and our next one would be sauce. So put it this way, and then we could say text block text equals binding path equals sauce. And the difference between these two, let me pull paint back up here for a second, is that, whoops, the first one, the text block with the string format, is going to display like this. Size small. And the second one actually is two text blocks. So one is going to be displayed above the second one. So it'd be sauce, and then let's say it's honey barbecue. That would be displayed on the next line. So those are two different ways of doing that. I don't care which one you do, but you do need to make it clear to the user what you're displaying. And this is a very, very common mistake that computer scientists make, is we don't give the user enough support in our user interfaces to help them really understand what the user interface is displaying. So I really expect you to add a label to anything you're displaying unless it's just completely obvious what it is. And just because you think it's completely obvious doesn't mean your users will. So it's best to just always have a label of some kind. Then we do price and calories. Let's go ahead and do those with the string format, because I want to show you one more thing. So price, and price we know is going to be a decimal or double. We're not quite, it's actually a decimal in this, double in this test, but it would normally be a decimal as we're working with it, which means we want to format it, and specifically we want to format it as currency. So we could say string format equals price, colon, $sign, and then put our 0 there. But there's another trick we can play, is we can just say string format price, do a colon C, which says format this as currency, so that what we're going to drop in there will have a $sign, and it will have just the two decimal places to match US currency, which is probably the region this program is going to be running. So there we go. That gives us the price, and calories is pretty much the same way. And colon. All right. One other thing to say here is if you chose to do the two property one with the price, So we have a text block, text equals price, colon, and then we drop down a line to do text block, text equals binding path equals price. And we want to do a string format. And we just want to render this as currency with no string in front of it. A number of you ran into this. You want to do a curly brace to say that the format string is empty, because we aren't using double quotes for the format string. It has no idea of how to tell it's empty unless you do the curly brace, and then you just do a C after that to indicate, I think it's either C or colon C, to indicate that you want to use currency for that. So that is something that a few of you ran into. The other way you can do it is you can just do the C as well without the curly brace colon. So just some things to keep in mind as you're working through that. All right, question 10. Write an implementation of Hag-Raven Wings, assuming the price is $4.50, medium as 5, large as 550. It should have a size property corresponding to the size enum. It should have a sauce property from the dipping sauce enum. It should implement a name property that identifies it as a size Hag-Raven Wings, where size is replaced with the actual size. It should also have a special instructions property, which returns a list containing a string corresponding to the selected dipping sauce. Finally, it should implement the iNotify property changed interface. And this is the Hag-Raven Wings we also have here, so we need to know that we're going to implement from entree, and from there we'll get the iMenu item as well. So this is question 10. So we're going to do a public class Hag-Raven Wings, and we are going to extend entree. We are going to extend iMenu item. It's not strictly necessary that we list this one because we get that from the entree, but it doesn't hurt to list it. And then we want to do iNotify property changed as well. Okay, because we have done iNotify property changed, we have to implement the iNotify property event, which is going to be a public event notify, the type is, property changed event handler, and the name is property changed. And it is always property changed. You can't, this has to be exactly the same anytime you implement property changed. Then we can do, if we want, we can write the helper method to do the onProperty changed, or we can invoke it directly. It's up to you as to how you want to do that. It's not listed here as a public method, so if you do a helper method, it needs to be protected. That's the common way we do that, so that just this class, anything that derives from it, can actually use that. But a code from outside of those two places can't. So we said we wanted a price, calories, a name, a special instructions. Let's start with our price. Public. And this is listed as a double. It will be a decimal if we do something similar, because we really want to use decimals with prices. And we had a get only property. And so we're going to have a get. And inside that, we need to return whatever that double is. And if we go look at our description again, price is $4.50 for a small, $5 for a medium, and $5.50 for a large. So it depends on the size. And I realize this is pretty small. I'm going to up our view just a little bit. Maybe. Do that in this particular, yep, there we go. So I'll make this a little bit bigger, a little bit easier to see. So we can do this with a switch case where we look at the size property, which I don't have defined yet, but that's okay. And if the size is small, we are going to return the $4.50. If the size is medium, we're going to return $5. And if the size is large, we're going to return $5.50. Now, we might think that we've covered all our cases because these are the 3 valid enumeration values, but remember this size is actually represented by the compiler as an integer or some other numeric, and there are a lot more possible values it could be than just those 3. So we do need to have a default case, or this code will not compile. And here we'll just throw a new not implemented exception. And I like to throw a string in there describing what the problem was. So we'll say unknown size. And we'll just put in whatever that size property was. If you do it with an if statement, you kind of have to do the same thing. So let's do the next one, which was the calories, and we'll do that one using an if statement instead. So, oops, didn't mean to delete that. Boom, boom, boom. And let's get this up where you can see it. So now we're going to do a public uint calories. In fact, I'm going to collapse this so we can see it a little bit better. So we have our get. Again, calories is get only, and it's based on the sizes. And if we go look at the calories, oh, I didn't actually have a calories described there, but we had a calories listed down in here. So on your actual exam, I won't have a missing piece like that, or if I do, let me know and we will correct that. But let's just assume the calories are 100, 200, and 300. So we would check to see if size equals size.small, and then we could say return 100 for a small, else if size equals size.medium, return 200, and else if size equals size.large, return 300, and then here we would throw new not implemented exception with that unknown size. So it doesn't matter if we do a switch case or if we do if statements, we still have to deal with the fact that there could be a different value. Some of the other ways you don't necessarily have to use else ifs. We could just make these all be ifs. Or we could, at the last case, just return the value for the last one, in which case we would, if it's not a medium or a small, if it's anything else, large or anything else, we return 300 calories. I don't really like that approach, especially for this, because you're pretending you have a value for when you don't have a value. That's why I prefer the not implemented exception, because it's a lot clearer. If, on the other hand, it was a property that wasn't something like price or calories, where it really was okay if you had a default that you just fell through to some kind of default value, then that would be appropriate. But when we're actually working with measurable quantities and we're acting as a authoritative source of that information, we really don't want to just wing it and say, well, it's probably something like this, if we don't know what we're dealing with. So throwing an exception is really the right way of handling that in that case. Okay, so that was our calories. The name, and the name property is supposed to have the size in it. We're going to have a public string name. And again, this is a get only property, so we can write it this way, and get, and then inside that, return, and we want the string where the size property is embedded, so size, hag, raven, wings. So this would be invokes the toString on size. This is the same as saying toString. Just be whenever you concatenate something into a string, it does invoke its toString. So that's perfectly fine. You might also see it written like this. If you do it this way, it is very important that you include a space there. Otherwise, it's going to be large Hagraven wings, where large and Hagraven are concatenated together, and that's not what we want. There are some shorthands we can use as well. For example, we could use the lambda syntax on the get and just do that little arrow. Or, because the name is a get-only property, we could use lambda syntax directly on the name. So that's another way it could be written that is very concise. Any one of those would be perfectly fine. And then special instructions, which contains a list containing a string corresponding to the selected dipping sauce. So public, and this is probably an IEnumerable. Special instructions. And we can take a quick look at our UML, double check that's an IEnumerable in this case. Special instructions. In this particular exam, it's actually listed as a list. So it is important to check those things. So we would return, in this case, a list of string, whereas we've been using IEnumerables in our class, which is also potentially a list. And then we just have our getter. We're going to create a new list of type string, save that in a variable, special instructions. There are some different syntax we can use for this. One that was introduced in C# 9.0 is list string, the name, and then because we have the type right here, we can actually abbreviate the new constructor just be new with the parentheses. So that is something that came new in C# 9. You might see this in practice sometime. That's what it is. In order to use the new without specifying the type, you have to declare the type of the variable, and this all has to be a one-line expression because we want other programmers reading our code to be able to immediately say, oh, this new corresponds to a new list. That makes sense. I get it. And we can say if, or actually, doesn't matter. We always need to use add to that list the sauce. Then we can return si. Are there other ways of writing this? Absolutely. We can use initialization syntax to say that we're going to add sauce like that. This just adds these items to the list. Sauce, because we're adding to a list of string, it's going to invoke the toString. So we don't have to do it toString explicitly, but we could. And this just creates a new list that is that. And in fact, we wouldn't even have to store it in a variable then. We could just return it directly. Of course, if we're doing that, now we're not specifying the type, so we can't use this new construct. We'd have to say new list of type string. But that would be one way we could do it as a one-liner, and if we did that, we could, of course, use lambda syntax, and we could also, because it's a get only, we could use lambda syntax here. So if you haven't noticed, a lot of the syntactic sugar that has been introduced to C# is all about making it quicker to write code. And that's really always the purpose of syntactic sugars, make it faster and easier for a professional to write code. The downside is I just showed you 4 or 5 different ways you could write the exact same method that are very different from one another visually, which makes it much more of a challenge to learn and also read somebody else's code, because now you don't need to know just one way of writing it, you need to know all 5 ways of writing it. So that is one of the takeaways that I hope you get out of this class, is that with most professional programming languages, there's many ways of expressing the same idea, and if you're going to be a professional programmer, you can't just know one, because you're going to read other people's code who may be doing it differently than you have learned to do it. So you really do need to be at least familiar with all of the ways of writing that code, even if it's not something that you like to use yourself. So you should be able to read it in all those different forms. All right, let's make sure that we've answered the question fully. We did the price, the size, the sauce. We did not do. Let's do a sauce. Sauce and size we still have to do. Public, size, size. Can we do a get and a set like that? Because it is both a get and a set. Size we have a get and a set, and sauce we have a get and a set. So it's tempting to say, oh, let's just do it like this with an auto property. But remember, we are implementing property changed. So we have to notify whenever we change something that is changing. So we can't use the auto property syntax, which means we need a private backing field, size underscore size, and we didn't specify a default, but we could use size.small. Or honestly, if we just set it like this and we don't have that there at all, it's going to default to small because that's the first thing in our enumeration. Okay. So we have to write our getter and we have to write our setter. Our getter is pretty straightforward. It's just going to return that size. And our setter is going to be a little more involved because it has to actually deal with not just setting that, which is going to be simply setting our size property to the value, but then we have to notify of what is changing. And this is where it might actually behoove us to write that private method, because otherwise we've got to do a lot of invokes, and that's a lot of writing invoke. So let's add a protected void on property changed string prop name, and this would be property changed. Remember, with events we want to use that question mark period syntax. This tests that property there's actually event listeners attached, otherwise it doesn't do the next step, which is invoking. And we're going to invoke with this object. The Hagraven Wings is the source of the event, so that's this, and a new property changed event args. And we're going to pass in that prop name so that it says this is the property that's changing. So now we can come back down here and add our on property changed. And the property that's changing is our size. And we like to use name of, because that prevents us from misspelling that name and making sure that we're tying it to the property, because Visual Studio will check that. We could have also just done the string size. Now, is that the only thing that changes when our size changes? Well, our double depends on the size, or sorry, our price. No, I don't have a price in there. Whoops. Price depends on the size, and so does our calories. And so does this name, because we use the size in the name. So all of those need to be notified that they're changing. And name. There we go. And the same thing for the name property. Or sorry, not name property. We need to do also the public size, not size, dipping sauce. Sauce. Having some typing issues. And again, our get is just going to return that. sauce variable, and our set is going to have some logic in it where we're going to set the sauce equal to the value, and then we need to notify of all the things that are changing. The sauce property is the easy one. It's obvious it's changing. Does our price depend on the sauce? No, it does not. Calories does not. Name does not. However, special instructions does depend on the sauce, so we need to do that one as well. So special instructions will change with the sauce. Okay. Have we finished special instruction size, sauce, property changed? We do have a toString in here. It doesn't say in the actual description, I don't think, but we'll go ahead and implement it. Override toString. And here, we're just going to return our name property because that's already constructing a nice description of it. So that's an easy way of doing that. And again, there are other ways of writing this. We could use lambda syntax because we're just returning a name. And when we use lambda syntax like this, we don't actually have to have the return. We can just say this is the return value. And we always have to have the type in here. And finally, this has to be an override because toString is declared on the class object, which is a base class of all objects. There's basically two properties that are methods that are declared there, which is toString and toHash. And anytime you write one of those methods in one of your classes, you have to override the existing one. And that wraps up, I think, the last question on our practice exam. So hopefully that gives you a good picture of what we're going to be doing. I will see you guys next week. Section A on Monday, Section B on Wednesday, Section S on Friday. And good luck.